Welcome and thanks for stopping by at the eCave. As you see here on my left, I've got an old Ibm Pc Jx. However, I'm not going to talk about that in this episode. I'm going to talk about the Ibm Pc Jx. Yes, it's a rarely seen PC and hasn't been featured before to my knowledge. So, if you don't know anything about the Ibm Pc Jx or want to know more, stick with me. Thanks for staying. The Ibm Pc Jx is a machine that originated in Japan in the mid-1985s. However, before we sort of show you what it does and the ports and things like that, I want to talk a bit about the history of the machine. Now, when it comes to history, it's always difficult to know how far back to go. But I've decided to go back to May 1979 in Japan. Now, thankfully, I've been working on another project and I built a time machine, which you can see over here. And what I'm going to do is to send a younger version of myself back to Japan to May 1979, and I'll talk about the machine once I get there. So I'll show you the time machine and then we'll swing it into action and see what happens. Now, as you see here, I've got to turn it on. I've got it pre-programmed and set for this particular date, which I'm going to travel to, and where my younger self will give you a presentation. So we're going to the 9th of May 1979. And hang on, the flux capacitor is just charging up there. Good. Now we have to check the status. Flux capacitor is green, the time coil is active, we've got the GPS lock, and the alignment is good. Okay, now the time travel is active, so we can go. So to go, we'll have to take it. And I have to hold it because otherwise it won't teleport myself. So let's get ready. Are you ready? I'm ready. Something's happening.
Fjórða bekk úr, þar sem fer fram verkleg kennsla. Það eru þó nokkru margir nemendur hérna.
Fantastic. Unfortunately, my younger self went back to 1974 and a different country speaking a different language, so I apologize for that. Obviously, some of the programming isn't correct here, and despite the status lights being correct, something's amiss, so I'll have to go back and do something else with this machine. So I'll put it away for the time being. And hopefully I can use it in a later episode. So let's put that back here and start talking about the history of the Ibm Pc Jx. We'll just use some traditional methods. As mentioned before, the Ibm Pc Jx originated in Japan late 1984. I just want to set the scene first before we get there. For that, we have to go back to May 1979, when the Nippon Electric Company, better known today as the NEC Corporation, introduced a portable computer in Japan called the PC 8001. It became available in September and was one of the first computers sold in the domestic Japanese market as a complete machine, i.e. not in a kit form. As you can see, it was quite similar to the Tandy TRS-80 console. It had a 4 MHz Z80 compatible CPU and came with 16 or 32 kilobytes of memory. It had some limited graphics capabilities built into it, which produced 160 by 100 pixels with 8 colors. The character ROM also included kanji characters. However, due to the limited graphics, it wasn't very good. This machine became very popular in Japan, and in 1981 it dominated the market with about 40% market share. NEC went on to release updated versions of the machine with better graphics and more memory. This machine, PC 8001, was discontinued in January 1983. NEC even sold localized versions of this machine in the US, Canada, Australia, New Zealand, and some countries in Europe. They tend to be very scarce, so if you do find one, hang on to it. Next, we move to the United States, where IBM announced the Ibm PC in August 1981. So let's talk about that for a bit. When the Ibm PC was launched in 1981, it was a major event in personal computer history. However, I rarely hear people talk about the fact that it was only launched in the US, nowhere else. It was not launched worldwide. You may wonder why that is the case. Well, it wasn't just the fact that IBM couldn't initially supply the demand in the US. The main reason had to do with the fact that it was launched with a code page table called 437, which supplied the ASCII character set, and it was hardwired to use that. This codes page fully supported the English language, although it did contain a few national language characters. Those were located in the upper part of the ASCII table. If you look at the ASCII table today, you come to realize that the only 3 full alphabets in the table are for English, German, and Swedish. Now, why German and Swedish, I don't know. If somebody knows, please make a comment. However, even in that case, that didn't work very well for Germany or Sweden, because to access the national language characters for those alphabets, you have to resort to the cumbersome method of using the alt and 3-digit number to get those characters. They weren't by default on the keyboard. So you can say that the only language supported by the Ibm PC on launch was US English. The other thing to note is that not every country where IBM operates launches every product IBM makes. The key reason for that is each country has their own markets, and they have to wear the cost of adapting IBM products to their own market, and therefore they have to assess as to the feasibility of selling the product. When it came to the IBM PC, all of them, or most of them, wanted to market the PC, so they all embarked on a national language adaptation process, which is a fairly involved process, especially in the early days. The first thing they had to do was to create a codes page table to support their national language. Some of them did their own tables, others shared tables. The next thing you have to do is to get the character ROMs and have them replaced on the display adapters and the printers. Then you have to modify the layout on the keyboard with the new keycaps. You have to translate all the documentation which comes with a PC. And then a lot of the bigger countries went even further. They actually took the DOS operating system and modified it in order to show all messages and having the ability to enter commands in their own native language. Now this whole process led to the creation of over 100 code page tables, which you can look up on Wikipedia. Some are shared by some countries, others have their own native one. This language code page table wasn't solved until the early 90s with the finalization of the Unicode standard, which is now in place. Of interesting note is that the current Unicode page table contains over 143,000 characters, whereas the good old ASCII 437 code page table only had 256. So we've come a fair way since then. So it wasn't until 1983 in January that Ibm PC was announced to the world and became available in other countries outside the US, and including their own national language. Now you might think that IBM Japan would have jumped on the opportunity and nationally language adapted the PC and launched it in Japan, but that was not the case. They didn't launch the IBM PC in Japan, and they didn't launch the IBM XT PC in Japan either. This probably came down to the fact that given the cost of doing the language adaptation, plus the technical capabilities of the IBM PC and XT to display and produce the complex Japanese language, wasn't worth it. They were probably under-resourced to do that. So IBM Japan simply decided not to market the PCs. Now NEC and the other Japanese computer manufacturers didn't sit on their laurels and continued to pump out personal computers in the Japanese market. In fact, NEC launched a PC called the PC 9801 in October 1982, probably seeing the success of the IBM PC in the US. So let's talk a bit about the 9801. The first model of the PC 9801 was a desktop model like the IBM PC. In contrast to the IBM PC, the CPU they used was an 8086 running at 5 MHz. It came with 128 kilobytes of memory, expandable to 640 kilobytes. The graphics capability supported 640 by 400 pixels with 8 colors. It also supported the English language, but primarily it supported the Japanese language as well, although not as well as is done today. NEC continued to improve this series of personal computers and released enhanced models at least once a year and often multiple times in a year. At one time, it's estimated they held about 60% of the personal computer market in Japan. In the end, NEC discontinued the series in 2003 after having sold over 18 million systems. It wasn't until 1986 that NEC began selling the IBM-compatible APC4 with Roman numerals PC outside Japan. The early success NEC had with their personal computers prompted IBM Japan to begin to develop their own personal computer aimed at medium to large businesses. The process began in early 1981, and they ended up releasing a computer in March 1983 called the Ibm Multistation 5550. The Japanese Ibm Multistation was designed to be able to do personal computing, but it also could act as a remote terminal to mainframe. Now, one of the key design specs was its ability to produce and display the Japanese language a lot better than all the other personal computers at the time. And this is perhaps one of the reasons the IBM PC was never marketed in Japan by IBM, because in order to achieve the good Japanese language capabilities, the 5550 ran an 8086 processor clocked at 8 megahertz. The base system had 256 kilobytes of memory, expandable to 512 kilobytes, but the graphics capability was a resolution of 1024 by 768 pixel, which was quite a lot at the time. In monochrome though, it was less using color. This allowed them to display complex kanji characters. Now, at the time, IBM Japan didn't have their own capability to mass produce personal computers, so they had to outsource it to someone else. Now, one of the major ones that actually created the IBM 55 Multistation was an electronics manufacturer called Matsushita Electronics Industrial Corporation. Quite a mouthful, I'm afraid, but it's easier when you know it's called Panasonic today, so they changed their name later on. They actually made the system units and the monitors. Now, at the time, the IBM Multistation was much more expensive than the existing personal computer in the market. Despite that, it immediately became quite successful with the large businesses and enterprises in Japan. IBM Japan continued to release updated models of the 5550 until it was discontinued in 1989. By then, it had been taken over by another IBM system called the PS255, which became quite successful in Japan. So, going back to March 1983, when the IBM Multistation was launched in Japan, a couple of other things were happening at the same time. Over in the US and worldwide, IBM was launching the Ibm Pc Jx. They were also launching the Ibm Pc Jr. As far as I can tell, neither the Ibm XT 5160 or the Ibm Pc Jr. were marketed by IBM in Japan. I gather the main killer for the Ibm Pc Jr. from a Japanese perspective was the poor performance and the horrible chiclet keyboard. This is quite ironic as we begin looking at the Ibm Pc Jx later on. What we do know now, though, is that IBM Japan were beginning work on the design of an entry-level PC in order to be able to enter the personal computer market and compete with the likes of NEC. So next we move to August 1984, when IBM announces the Ibm PC 8E 5170. Once again, as far as I can tell, this model was also not marketed by IBM Japan. I can only assume they were busy finalizing the build of the Ibm Pc Jx, as it was announced just a few months later in November 1984 for the Japanese market. Just a few months later in April 1985, IBM Australia and New Zealand also began selling the Ibm Pc Jx in their countries. So these are the only three countries where the Ibm Pc Jx appeared in. And finally, towards the end of 1985, IBM in Japan quietly began selling a second version of the Japanese model. This means that there are three different variants of the Ibm Pc Jx. They all have the same model number of 5511, but they have three different motherboards. So before we get into the technical nitty-gritty, let's talk a bit about the design of the Ibm Pc Jx. When I look at the technical implementation of the Ibm Pc Jx, I can only speculate as to what the designers had in their minds when they were designing the machine. I suspect they were trying to aim for different market segments within Japan. I think the primary idea was to make it compatible with the small business market. Secondly, they wanted to sell the machine into the education market. And thirdly, they were aiming for the domestic games market. That's why they put a cartridge slot into the machine for games. The way they implemented this capability was to give the machine 3 different operational modes. And when I say mode, what I mean is when the machine boots, it will enter one of these 3 different modes. The default mode was called the native mode. In that mode, it would activate 2 video processors on the motherboard, and it would then be able to display and use the Japanese language. Although the graphics resolution was only 640 by 200 pixel using 4 colors, which is the same as the PC Junior has. If you wanted better Japanese language capabilities, you could buy an extended video card and put into the machine. It also came with a cartridge, and you had to put in the cartridge, and when you booted the machine, it would enter the extended video mode, which gave it another video processor. This allowed the machine to operate in graphics mode up to 720 by 512 pixels using 2 colors. It also gave it some enhanced Japanese language capabilities like grid lines. And in this extended video mode, this machine was said to be compatible with the IBM 5550 Multistation. And then, if you wanted to have it in the English mode, which was the 3rd mode, you could buy a cartridge, put it in the cartridge slot, and when it booted, it would become an IBM PC Junior, just like the Junior itself. And it's actually compatible with just about all the games and cartridges, so you can play PC Junior games and cartridges on the machine. Now, before I continue talking about the design, let's look at the technical specs for the machine, because I'm sure you're interested in knowing what actually drove the machine. As I mentioned, there were 3 versions of it, i.e. 3 different motherboards. The machine IBM Japan launched with came out in different configurations, so they called them JX1 to JX4. That system unit had an 8088 processor clocked at 4.77 megahertz, exactly the same as the IBM PC Junior, and the IBM PC or the XT as well. So it wasn't a faster machine by any measure. In addition to that, it lacked the DRAM refresh capability, so it was slower having to refresh the DRAM via the processor. Now, the Australia-New Zealand version is based on that particular motherboard. They basically took out some of the video processor or gate array chips and left it with 1 video processor similar to the IBM PC Junior. Still the same 8088 clocked at 477 megahertz. But as I mentioned, IBM Japan released or discreetly released a JX5 model in late December, early January 1985. What they did there, they must have reworked the motherboard, which I'll show you in a different video. They basically added in a card you can plug into the motherboard with a higher clock speed 8088 and put some bot wires on the motherboard itself, and then a turbo switch on the front right side of the system unit. And if you put the turbo switch on, it would run at 7.2 megahertz. So it gave it a fair bit of speed boost. The JX5 I've seen has been referred to as 5110. That is not correct. It has exactly the same model number, 5511. This 5510 number comes from the technical manual, or the technical reference manual for the machine, which was published in English in October 1984. That technical reference manual refers to the machine as 5110. I suspect what it means, it was supposed to be a series of machines called the 5110 series, and the 5511 was simply the first machine in that series launched. In addition to the machine, in Japan they launched 3 monitors, a 12-inch monochrome monitor, a 12-inch color monitor, and a 14-inch color monitor that supported the higher resolution if you were using the machine with the extended video card. Now I'll talk about the specs, and I'll show you the specs in detail. I've collected this information from various sites and pulled it into one spreadsheet or graph. So let's have a look at that. The first overview I'm showing here are the specs for all the Japanese models, which are called JX1 to JX5. I've included information on the expansion slots as well. In order to make sense of the expansion slots, I'm adding a photo of the Japanese motherboard where you can see the expansion slots and what they are for. I won't read through this, as I'm sure you can pause and run through it at your leisure. The next overview is a chart for the 3 monitors offered by IBM Japan at the time. Please note that the middle one, i.e. 5512-2, is the monitor IBM New Zealand supplied with the system in Australia and New Zealand. The third overview are the Ibm Jx Printer Models, which I believe were rebadged Orgi printers. Next come the configuration and specs for the systems launched in Australia and New Zealand. As you can see, those models only offered 32 kilobytes of video memory, whereas the Japanese version went up to 64 kilobytes of video memory. The next overview shows the options available for the Ibm Pc Jx in Australia and New Zealand. Some of the options could only be installed into the 5519 expansion unit. Note that the prices are in Australian dollars as they were at the time. The last overview shows a summary from the Ibm Pc Jx Technical Reference Manual. It details how the Ibm Pc Jx was compatible with the Ibm PC Junior. I'll put a link below to the excellent PC Museum webpage maintained by Anthony Beckett. He has a few of these machines and has been gathering information and scanning some of the documents and make available for download. You can certainly get the technical reference manual from there. So to continue, let's talk a bit more about the design now that you have seen the specs. Another design criteria for the machine was pretty weird. Instead of giving it the 5 1/4 floppy drives, which were pretty common at the time, they decided to give it 3.5-inch 360K floppy drives. When I say 360, they were actually 720K drives, but the BIOS in the machine only supported 360K. So what did they do to compensate for that? Because everybody else was using 5¼ drives, or maybe not everybody else, but a lot of businesses and home users. Well, they created an expansion unit. And in the expansion unit, they have the 5¼ drive. It's a strange machine, strange design, and I'm not surprised it failed. It failed even faster than the Ibm Pc Jr, because that sold at least in the hundreds of thousands. I gather around 400,000 PC Juniors were sold. In this machine, IBM Japan made about 40,000 machines, but it said they sold less than 7,000. So when it came to the IBM Japan 50th anniversary in June 1987, they offered their employees a gift, and they could choose between having a Ibm Pc Jx or a coffee mug. I gather a lot of them took the coffee mug. IBM must have had a lot of them in stock, and they simply wanted to give them away to get rid of them. Now, when it comes to the Australian New Zealand version of the machine, they stripped out all the Japanese capabilities. So it only has one video processor, exactly like the PC Junior. They also brought over the 12-inch color monitor for the 640 by 200 pixel resolution, because in the English mode, that's the only graphic resolution it supports. The model number of the Australian New Zealand version of the monitor is 5515 2E1. I guess the E1 means it has a 240 volt power supply rather than the 110 one, which is in Japan. Another interesting fact before we go and look at a machine is IBM Japan didn't make this machine by themselves. They outsourced the manufacturing of the machine to Panasonic. So Panasonic made the motherboard, system unit, and the monitors. In Japan and also here in Australia, they did supply some Pc Jx printers, which I gather were made by Oki in Japan. In Japan, when they launched the machines, they were available in beige or this dark grey color like this machine. So consumers or buyers could choose the white version or the grey version. However, when it came to Australia and New Zealand, they were all the same slate grey color, so you didn't have a choice. Another interesting design criteria, perhaps the market in Japan was more critical of the colors than here in Australia. But I've talked enough about the machine. How about showing the machine to you? Now, I do have a complete unit here, but I guess you will also want to see the expansion unit. So let's make that happen as well. Voila, here it is with the expansion unit. So I'll bring you a bit closer so you can see close up what the machine looks like. So let me do that first. Well, I'll try not to get in the way, so let's get started. First of all, we have the keyboard. This is the English version of the keyboard called the compact keyboard. It was supplied here in Australia with the machine. You could also get an extended keyboard, which was an optional extra. This keyboard is like the IBM Pc Junior. It has infrared and it also has a PS2 cable. So you can either use the cable or the infrared. The infrared receiver is here on the machine. Now down here you see the two cartridge slots like on the Pc Junior. And then the 360K, or in fact the 720K drive is in the main system unit. As I said before, the drive is actually capable of 720K, but the BIOS in the machine doesn't support it. And as you can see, this machine here comes with the expansion unit. And in the expansion unit, we have the 5¼ floppy drive. The monitor, as I said before, is a 12-inch color monitor, CGA compatible, 640 to 200 pixels with 2 colors. That also depends on how much memory is in the machine. Another thing they did was they put a speaker into the monitor, because the audio chip on the system board is the same one as in the PC Junior. Therefore, you have a volume control and a brightness control for the monitor itself. Now, if you look at the back of it, it comes with a few ports. First of all, you have the power port or AC input, which goes in here, and then on the system unit is an expansion AC connector for the expansion unit. So normally this is vacant if you don't have the expansion unit. Then the next you have is the PS2 keyboard connector, so you can wire it up to the keyboard rather than use the infrared, which I gather wasn't very reliable. Then you have the display adapter. This is basically a DB15 connector, but it's CGA with the audio also being piped to the monitor. It's quite easy to create a DB15 to DB9 plug to use a normal CGA monitor. Next, the machine did not come with RS-232, and that's what it is here. It has an expansion slot inside, and this would be knocked out and you would have an RS-232 port here. It also has 2 joysticks, so you can play games on it. There's a parallel printer port, and then there's a separate audio out. This is an RCA jack, whereby you can pipe the audio into a different audio amplifier system. There's a cassette port, because if the machine doesn't have any operating system, it defaults into Basic, Microsoft Basic. And then for whatever reason, they have a light pen interface, which is so rarely used, it's hardly worth talking about. You can also see that the model number here is 5511. The model number of the monitor is 5515 2E1. And then the expansion unit was called 5519. And because this is the Australian version of the machine, it is all 240 AC powered. Now let's plug it in and power it on, and I'll see if I can play you some games. I've now hooked the machine up, so let's power it on. First we fire up the monitor and then the system unit. I love these good old IBM red power switches. You obviously recognize the power on logo, which is the same as on the PC Junior. This machine has 256 kilobytes of memory. So as I said, you can expand it to 512 kilobytes, because there would be another board within the expansion unit to add some more memory cards. It defaults into Ibm PC Junior Basic version J.1. The machine came with documentation, as you have seen. It's basically Jx PC DOS version 2.1. this version here does not support the 720K floppy. It also came with the Ibm Jx Guide to Operations, and if you look at it, I'm sure it's very similar to the PC Junior guide, which is interesting. Now let's put in a floppy disk with this is PC Jx DOS 2.1 and reboot the machine. It takes a while to boot, as I've said before. It's not the fastest machine, with 8088 running at 4.77 megahertz. So it's basically an Ibm PC Junior. There we go. And we're in. Now, I'll run a game on it called Frogger. The Frogger is on the 5¼ inch drive. So to get to the 5¼ inch drive, it's called C. So it's the hard drive letter. So let's do C. Do a directory and Frogger. As you can see, it's not in the best condition. I haven't restored it yet, so you can see that the O key is not happy. So where are we? Type any other key to return. So one Frogger saved. I won't play anymore, but this is the machine. It has the sound capabilities of the PC Junior, which I can show you later. I think this is enough for now. What I'm planning to do is to bring part 2 out, where I strip it down and show you inside, and we can look at the different motherboards in the different versions, and I can point out what has been taken away in the English machine. So we'll call it quits for now. So if you want to see part 2, subscribe to get notified. Until then, thanks for stopping by at the eCave.